Alright, this problem is problem 17 from the review sheet. That problem is a physics student launches a bottle rocket into the air with an initial velocity of 24 meters per second. How long does it take the rocket to land back on the ground? Here's my rocket down in my bottom left hand corner. It's going to go up, 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 and then it's going to come all the way back down and land on the ground where it started. The velocity is upward. Here's my motion map, but it is getting smaller because my acceleration is downward. I took the time to write out my 5 variables. Now I just have to write the numbers that I have for each of those in the particular spaces where they belong. The first one I can always write in free fall stuff is 9.8 meters per second squared. That's negative because it's down. The initial velocity is 24 meters per second upward because that's the speed at the beginning of the problem. It's asking me for how long, so that's time. And the one that a lot of people miss is when it starts on the ground and ends on the ground at the exact same spot, is going to have a displacement of 0 meters. Now I'm going to use the equation that does not have VF in it, which is D equals V naught T plus 1/2 A T squared. And this is usually a quadratic solving for T, but one thing which is really nice is since displacement is 0, I'm going to plug that number in right away. Makes my life a little bit easier. And now I'm going to subtract my V naught T to the other side, so I get negative V naught T equals 1/2 A T squared. Now I'm going to divide by my 1/2 A and T from both sides. And when I do that, my T's over here are going to cancel, my 1/2's A's are going to cancel, and I get rid of that squared in the top, and I'm left with negative V naught over 1/2 acceleration equals T. Plug in my numbers, and for V naught I have negative 24 meters per second divided by 1/2 times acceleration, which is negative 9.8 meters per second squared. That's going to equal time. I'm just about out of room, but I think I can fit it. I should get 4.9 seconds for time. And that is problem 17.